Hi, Kirill. Let's start our follow-up session after your nice talk almost a couple of weeks ago already, or even, so sorry for being late with that because I was on travel. But anyway, let me ask some questions and let's chat a little bit about your talk. First, I meant to ask you to clarify what are the main sources of data or databases, data series you and your colleague are using to validate and check Dynamo theories and Dynamo models.
Hello, Grisha. I'm happy to address your questions about the data. And generally, first of all, of course, there is data for general solar magnetic activity. I probably show it a bit later because everybody knows sunspot series, butterfly diagrams, and I also mentioned polar facula data. But the pivot point of our matching theory with observations is the use of helicity. As I mentioned, we use proxy of magnetic helicity. Shall I share my screen for that? Oh no, sorry. Probably have to remove it. Boy. Can you see my screen?
Yeah.
That's not the page I actually wanted. Oh yeah. I mentioned that we use magnetic helicity as in two meanings. One is an observable quantity which varies with the solar cycle and could be used as a manifestation of the activity. On the other hand, it is used in theory deeply in the mechanism as a back reaction of magnetic field to the properties of the turbulent media and the ability of this media to regenerate magnetic field. So it is used for nonlinear back reaction of magnetic field to the media, and the data. Well, I think it's going to, yeah. The data I mentioned in my talk, that is, we use the longest available series of data, which is ground-based data. And the observations of vector magnetic fields from which we compute current helicity proxies or relative helicity proxies for both are just proxies of magnetic helicity, available from several observatories, but the most successful and useful information for theory is from the longest data. And those are in Huairou Solar Observing Station in China. The data cover nearly 30 years period. But of course, there was some gaps in this data and something changed in the instrument. But principally, the magnetic line, the spectral line, the magnetic sensitivity, and the aperture of the telescope didn't change. So from the very basic points, this is a systematic data series. Of course, it is a very complicated task to convert it to a fully systematic data, which can be used for the theory immediately. But that's the data. And I mentioned in my talk, I'll try to recover a few slides. Do you see they change? Hello, can you hear me? Oh, I can't hear you.
Yes, I can.
All right.
I just muted myself.
Okay. I know. Yeah, so the observational data for magnetic field and for helicity computed out of this magnetic field. And we have processed thousands of such magnetograms which cover the whole period of the two solar cycles with statistically significant bins. Each of these bins contains more than 30 individual magnetograms to construct representative student statistics. And then we use this in the meaning of ensembles of turbulent pulsations for a mean field concept of dynamo. And the main result and most striking result is the butterfly diagram of helicity, which shows that in the maxima of solar cycles, the hemispheric sign rule, giving the opposite sign of the two hemispheres, is obeyed, while in the beginning and end of each solar cycle, almost each, there is a certain area in time latitudinal in space, certain region where the hemispheric sign rule reverses. So that is a very important source of data, and we try to build it from different sources, but it is a lot more complicated from high-resolution instruments such as Hinode, for example. And the Hinode is operating for nearly 12 years, so it covers most of solar cycle 24 and a bit of cycle 23. So it is useful for studies of the solar cycle. For instruments which exist less time and have more higher cadence or more short-scale properties, the building average quantities which represent mean field quantities in the theory is more complicated. This is why it's very difficult to process data from, for example, HMI. While we don't say it is not possible, there are some works about that. But maybe in the future we can collect more data from other instruments as well. And finally, I show the data from the polar activity that was in the beginning of my talk. I mentioned that we have a dynamo wave, and this dynamo wave has manifestations in low latitudes and high latitudes, and the high latitude branch of the dynamo wave is shifted by phase from the equatorward wave, and also it has certain correlation of the poleward wave and the forthcoming equatorward wave. So the data on polar activity is also extremely important. But as the technology changed and the instrumentation changed, and instead of photoplates and films, about 20 years ago, most of observatories start using CCD cameras, and then the all counts of polar bright points of facula have totally changed, and it's very difficult to convert these groups of data to the same standard. So basically, it is not available for recent data comparing this cycle to the previous.
Okay, thank you, Kirill, for that detailed response on my question. Let me ask if you want to add anything yourself to your talk. Maybe you forgot something or want to sharpen something or emphasize. Go ahead.
Well, not really much. I would like to mention the reference which Alexander Getling asked me about the paper which shows some example of, sorry, that is some other file. Yes, the example of dynamo with helicity or with no helicity which still produces magnetic field. That is a very old paper by Andrew Gilbert, Uriel Frisch, and Anik Pouquet. Helicity is unnecessary for alpha effect dynamos, but it helps. And that is a paper basically about some specific case, the example for which you still have, you can get with a certain prescribed flow, you can get the regeneration of magnetic fields. Therefore, it is the alpha effect which converts toroidal energy from toroidal energy into poloidal energy, but the presence of helicity helps this process. So that's just mainly an example, a particular case. So its importance for building realistic models for solar dynamo may not be very crucial, but that's just a comment to address the question of Alexander about that.
Okay, thank you very much, Kirill. Thank you for your talk, for the follow-up session, and see you soon in our next webinars. Thank you. So, bye.
Thank you very much, and we'll look forward for that. Yeah.
Yeah, bye.
Bye-bye.